Today, we're going to crack open the hood on ScyllaDB. It's a NoSQL database that was built for one thing, and one thing only, just pure, raw speed. And the best part? It's completely compatible with the Cassandra ecosystem. So let's start with a question. Imagine you've got this classic, super reliable car. Let's say that's Apache Cassandra. Now, what if you could take that car and give it a complete Formula One engine overhaul? That's really the core idea behind ScyllaDB. It's not about inventing a totally new vehicle. It's about re-engineering a proven design to squeeze every single drop of performance out of modern hardware. And right here, you can see the fundamental difference. We're talking about a move from Java to C++, and that shift lets ScyllaDB get way closer to the metal, with much tighter control over system resources. So instead of all these threads competing for resources like they do in Cassandra, ScyllaDB gives each CPU core its very own dedicated lane. And the result of that? Well, it's performance that isn't just fast, it's predictably fast, with incredibly low latency. Okay, so how did this high-performance monster even come to be? You know, to really get ScyllaDB, you have to understand the why behind it. It's a story all about seeing massive potential in something and then just pushing it to its absolute limit. It all kicked off back in 2014. A team of engineers who had this deep experience in virtualization from their time at Red Hat and working on KVM, they set out on this mission. But first, they built a brand new C++ framework from the ground up. They called it C*. And that became the engine for ScyllaDB. From the moment it launched, it was pretty clear this wasn't just another database. Nope. This was a fundamental rethinking of how to get scale and speed. Now, this is key to their whole philosophy. The founders didn't want to throw out all the brilliant ideas behind Cassandra, its data model, its APIs, its distributed nature. They just wanted to perfect the execution. They wanted to solve those architectural bottlenecks that were holding it back on modern multi-core servers. All right, let's get a little technical now and really look under the hood, because this is where ScyllaDB truly separates itself from the pack. We're about to see exactly how that C++ rewrite translates into a completely different internal design. So the most crucial point is this. Everything, and I mean everything, flows from that one decision to rebuild the whole thing in C++. And look, this choice wasn't just about picking a different programming language. It unlocked an entirely new architectural paradigm that you just can't do in the Java virtual machine world where Cassandra lives. And the foundation of that whole rewrite is C*. Seriously, think of it as the custom-built, high-performance engine block that ScyllaDB is built on top of. It's designed from the ground up to manage resources at this incredibly granular level, letting ScyllaDB talk directly to the hardware and to sidestep all the common operating system overhead. And this all builds up to what they call the thread-per-core architecture. It's beautiful, really. Each CPU core gets its own dedicated thread, its own dedicated RAM, and its own slice of the data, which is called a shard. And because absolutely nothing is shared, there's no fighting over resources. This completely gets rid of slow context switching. That time a CPU wastes when it has to stop one job to work on another. Here, each core is basically its own self-sufficient, highly efficient little database engine. So what's the payoff for all this brilliant design? Well, it's huge. You get that predictably low latency, which means a snappy, super reliable user experience. You get massive throughput, so you can handle enormous amounts of data. And because the clients are what they call shard-aware, they can talk directly to the specific core that holds their data. And maybe best of all, it scales linearly. You add more cores, you get a predictable boost in performance, no surprises. Okay, a powerful engine is fantastic, but you need the rest of the car to go with it, right? A database isn't just about raw speed. It's about the whole ecosystem of tools that make it usable and manageable and just powerful for developers to actually build on. And the ecosystem around ScyllaDB is really robust. You've got Scylla Manager for handling all the boring admin tasks, a fully managed Scylla Cloud option if you don't want to run it yourself, and critical developer features like change data capture. Plus, it plays nicely with all the tools you'd expect. Things like Kafka and Spark for data processing and Grafana and Prometheus for monitoring. But hang on, I've got to call special attention to this one, Alternator. This is an absolute game changer. It's an API that is compatible with Amazon's DynamoDB. And what that means is you can run your DynamoDB applications on ScyllaDB, whether it's on-prem or in any cloud, without changing a single line of your code. It's a really powerful off-ramp from vendor lock-in, and it gives you so much more control over your costs and your infrastructure. Okay, so we've got the theory, we've got the tools, but what does all this power look like out in the real world? Where are teams actually putting this high-octane database to the test? First up, real-time analytics. Think about things like fraud detection or live user dashboards. In those scenarios, you need to query massive datasets and get answers back in milliseconds, not seconds. That kind of speed means you can spot an issue and react instantly, which could potentially save millions of dollars or just keep a customer happy. That low latency of ScyllaDB makes it a perfect fit. Next, imagine that relentless fire hose of data you get from IoT devices, everything from smart home sensors to industrial equipment. ScyllaDB's high throughput is literally designed to ingest and process these massive, constant streams of information without even breaking a sweat. For a company managing, say, a fleet of vehicles, this means real-time tracking and predictive maintenance, not just looking at reports after the fact. And finally, think about applications like ad tech or real-time messaging. In that world, every single millisecond counts. A delay of just a few hundred milliseconds could mean a lost ad bid or a really frustrating user experience in a chat app. Serving an ad or delivering a message instantly at massive scale is exactly the kind of workload ScyllaDB was built to dominate. It directly impacts revenue and user engagement. And hey, this isn't just theoretical stuff. We're talking about major tech powerhouses here. Discord uses it to handle their massive messaging infrastructure. Comcast relies on it for critical services. Grab uses it to power their entire ride-hailing platform. These are companies where performance isn't just a nice-to-have feature, it is their entire business. So let's bring it all home. When you put all these pieces together, the C++ rewrite, that thread per core architecture, and the really robust ecosystem, where does ScyllaDB truly fit in the whole database landscape? This comparison really lays it all out perfectly. Cassandra's strength is its long, battle-tested history. DynamoDB, on the other hand, offers this incredible managed simplicity. But ScyllaDB's advantage is that raw, predictable, core-level performance, combined with its totally unique dual compatibility with both Cassandra and DynamoDB APIs. It really carves out its own space for teams that need maximum performance without giving up flexibility. And that just leaves us with a pretty fascinating final thought. Maybe the next big leap forward isn't always about some brand new idea, but about taking a great, proven idea and just reimagining it for the incredible hardware we have today. ScyllaDB makes a really powerful case that sometimes the best way forward is just to build a better engine. Thanks for joining me for this one.